So welcome back everyone and welcome to our second session in the Microsoft stream. So right next to me we have Microsoft MVP Stacy Cashmore, I should say, sorry.
No problem.
And she will talk about debugging Azure static sites on Azure Web Apps actually. So Stacy is here and yeah, she is a Tech Explorer DevOps at Insane here in, sorry, I should say Omniplan. And yeah, she's actually insane for Lego, she told me. So everyone who is on camera, if you have anything special built with Lego, please show us. I'm sure Stacy will like it after her talk. But till then, please enjoy our session. And please go ahead, Stacy.
Thank you. And yeah, absolutely. If you've got some awesome Lego builds, please tweet it at me. I adore this stuff. And thank you so much for spending some time with me this evening. Now, over the last few years, there has been lots of awesome new technology that's been designed to make our lives as developers easier. It's easier to build our applications, it's easier to deploy our applications so that we can get our code out to our users with less effort on our part. Looking from the client side, that interface for the users, Blazor is a fantastic example of this, and specifically for our case today, Blazor WebAssembly. As a C# developer, I love being able to build my front end in the same language as my API, meaning I don't have to context switch between how I build my applications or the paradigms involved inside of it. And because it's WebAssembly, what we're dealing with today, I can load it from static files. I don't need that full-blown web server to get that content out to my users. Downside to that, of course, static files. I don't want my users to see just static things. I want to give them some dynamic content to make it really awesome. And for that, serverless functions are a fantastic help. Putting these two together, until recently, wasn't necessarily the easiest thing. If I go back a couple of years ago, I could deploy my static files into an Azure storage account and turn on the static web app inside of that. But I still needed my API to be deployed somewhere. And if I'm going to deploy that, then that's going to go into its own Azure function, which isn't just one Azure resource, it's three. You need the function, the app service, and the storage account behind it. They're now running in different locations. So either we've got to set up some interesting proxying to get them to talk to each other, or we've got to enable cores, which can be its own headache by its own thing. So all of a sudden, our simple thing that we're building, just this static front end, this function API, we're already running 5 services that we've got to keep a track of. This isn't the simplicity that I want. There is a better solution now, and that is the Azure Static Web Apps. They came into GA earlier this year. I've been playing with them since they've been in preview, and it is a wonderfully simple way to get our application into production. There's a free tier for if you're running it as a hobby, and there's a paid tier for if you need more performance, more networking, more security. And even that, when you're talking about paid resources, €7 a month, it's hardly that much. When we do this, our static front end, it's hosted globally for everybody to have access to. Our Azure function is inside that same single Azure resource, and it's proxied for us. We don't have to worry about connecting it. Cores has gone out of the window, the proxying's gone out of the window, one easy to manage resource. Now, all this sounds too good to be true, and it's just utopia and awesome. There's got to be a catch. And you know what? There is. When we deploy it into Azure, we have that one resource. We have that proxying. We have that one URL. When we're writing these things, we don't have that available to us. We are running our application on one port. We're running our API on another port. Suddenly, we've got to start worrying about things like cores again, getting the two things to communicate with each other. There's got to be a better way of doing this. And there is. I can't make that Azure environment exist locally for you, But let's have a look how we can cheat the system and try and pretend, shall we? So there's a few ways that we can do this. And when we first started using static web apps, the way that Microsoft recommended was to set up some interesting files in our project to get it to all communicate with each other. Now, whilst you don't necessarily need to do this anymore, if you're just running a simple application and you don't want to run anything on the command line, this can work for you. So I still want to quickly demo it for you. So what we're going to do is allow our client application to see where our server, our API is running. And then we're going to tell our API, you can really take requests from this client. It's OK. You can trust them. How are we going to do that? Well, we're going to add some development settings into our app. And we're going to start off in our client. This is just a simple solution with one Azure function at the top and a client at the bottom, which just sends some requests through. First thing that we're going to do is inside of the www folder, we're going to add a new item. And you're going to hear me say this a lot today. It's going to be JSON. So we're going to call this appsettings.development.json. And it's only going to have one setting in there to start off with. Let's just bring that across. I've got an amount of snippets because seriously, you don't want to spend the next 30 minutes watching me do typo after typo. There's enough of that when we get to the command line. So all this app setting is doing is just saying we have an API running on localhost 7071, the default port for an Azure function when you're running it locally. If you're running on a different port, obviously you're just going to need to change this, but it doesn't affect the rest of the process. Next thing we need to do is actually use this app setting. And for that, we're going to go into our program CS file, and we're just going to make a change to the way that our HTTP client is created and add it to our dependency injection. Rather than using the base address, which is the default behavior and the behavior that we want inside of our Azure resource, we're just going to bring in this builder configuration API prefix. If we have it, use it. If we don't, just take the default. It's fine. Now the client knows where it can get data from. We need to let the API know that it can accept the request. For that, we're going to come up and we are going to add a launch settings to our Azure function. And for that one, we're going to just call this our launch settings. Have I got that right? Yep. Nope, why did I make that as a CS file? That was stupid of me. Never mind. Let's bring some code in here. It is at least a JSON file, launch settings.json, so it should be working for us. What this is going to do is just say when we start this inside of Visual Studio, start it with cores enabled for everything. Now this sounds a little bit bad for security, but it's only running on your local machine. This doesn't affect your production. Last but not least, we need to start both the client and the API when we test this. So for that, we're going to come down to our startup projects. Instead of having a single startup project, we're going to have multiple, and we're going to start both. And we'll OK that. Now, when we run this, we'll keep our fingers crossed and hope that everything works as it's supposed to. And we'll be really nice to the little computer and say, please work. We have our Azure function started up. And of course, on the wrong screen, we have our browser. And here's our application loading. Now, I just want to open the console here because I want to show you that we are really getting our data from that 7071. So if we come to fetch data, I'm sure you all recognize this if you've ever spun up a new Blazor application. Normally, this comes from a JSON file. I've actually changed my application. So instead of coming from a JSON file, we get it from our 7071. So this is just a really simple way that we can get access to our application. And if we do this, we can put breakpoints in our application, and we can step through the code and work it pretty much as we normally do. So let's just prove that to you here. Let's put a breakpoint on line 6. I like doing it on line 6 because I think until .NET 6, this didn't work in Blazor. Not Blazor WebAssembly, at least. Let's stop our application and restart it. This should be quicker than last time, in theory. We'll see whether or not it's actually true. And there we go. We have our breakpoint, and we can now step through, and you can do all the things that you normally do inside of Visual Studio. So this is a really simple way of debugging our application and getting the two sides to talk to each other. You can't access everything inside of a static web app if you do this way, but as I say, if you're just using a basic client application and a basic Azure function to get some data, this will work for you. So what's the next step that we can do? Well, the next step is something that was released earlier this year, I believe, and that is the Static Web App CLI, an amazing command line interface which replicates the functionality of the Azure Static Web App. Now, wording is important here. When I say replicate, I mean it replicates it. It doesn't run an Azure Static Web App on your local machine. It just makes you think that there's one running there. This is great for debugging and for running through, but you've always got to keep in mind that it isn't exactly the same. It's only nearly the same. So how can we get this to run? Well, first of all, I'm going to do a little bit of cleanup because I've just changed code, which we don't need anymore. So let's get rid of those launch settings. Let's get rid of those app settings. And last but not least, let's change the program CS file back to what it was before. We all know, as a developer, best thing that we can do is get rid of code. Now, we're still going to start this initially inside of Visual Studio, because I just want to show you the simplest way to use the static web app to start with. So this is all going to run up. We're going to get our interface again, and if everything works, you should see an error, which is good. We can no longer communicate to that back end. So how are we going to fix this? Well, we're going to go to our command line. And inside the command line, we are going to start, if I can get my mouse, the static web app. And the easiest way to do that is if we just check what port we're running on, is just to say static web app, start, and I want to route all of my data to a certain place. And that's going to be HTTPS, localhost, and we're on port 7162. Now, when I start this, something that you're not going to see happen is a connection made to that API in the back end. That happens automatically. The Static Web App CLI knows that localhost 7071 is your API, and it will try and direct things there. So let's try and open this line, bring it onto the right screen, and here we have our application again. You can see we don't have that error at the bottom. We open up our network tab and go to fetch data. We can now see that we're getting the data from exactly the same port as we're getting our client side from. So this is the first simple way that we can run everything. We're still using Visual Studio to do some things, but we're doing some things on the command line as well. Next step. The next thing that I want to do actually is just get rid of running stuff inside of Visual Studio. If I'm on the command line anyway, I might as well do everything on the command line. So what we're going to do is stop Visual Studio. We're going to keep it open because I do want to edit my code. And I don't know if anybody else has had this, by the way, but Visual Studio 2022, if you're in debug mode, sometimes it's a nightmare to switch windows. I've heard other people complain of this as well. And it doesn't always affect me, but it definitely affects me when I'm giving a demo. So we've stopped that. Now nothing should be working anymore. We're going to get it all started again on the command line. For this, I am going to bring a command across because it's rather a lot to type. And we have a different command to start our static web app. We still have that SWA start. We now have HTTP localhost 5000 as where we want to look for our application because that's where it's going to run in a second. But we also see this API location ./API. What that's telling the SWA CLI is that our Azure function lives inside of the folder ./API. The CLI is going to look in that folder, and if it finds an Azure function, it's going to run func start so that we can use it. The last one that we see is this --run. This allows us to run an extra startup script when we start our CLI, and for here we're just simply doing .NET watch run. And again, because we're not in the folder of the project, we're just putting that --project.client. That's where our code lives. So let's paste this and run it. Let's keep our fingers crossed that I've got the ports correct. And hopefully, we should have something working for us. We can see that it's starting to build the API. We can see that it's found the client. Everything's building up, and we have the same URL. So let's go back to our application here, fetch data, restart this, and if everything's going to plan, we have our application again. Phew. Always a tricky one when you want to get that one right. Next up, say you're running multiple Azure functions and you don't have access to that 7071. Well, we have a way around this. We can tell the SWA CLI to use a different port for our Azure functions so you can run multiple together. So let's go back up to our previous command. And after API, we're going to put an API port equals 7073, say. Let's pick one out of the air. When I type this in, I always get like a knot in my stomach for this one because half of the parameters that we have, you do a space and then the parameter value. Half of them, you do equals. I don't know if this is because it's in preview or if this is a deliberate choice, but make sure you check the documentation to know how you need to use particular parameters. So let's run this one up now. We can see we're still using localhost 5000, but now we have that localhost 7073 for our function. Come back to our application, reload it from the front end. We see no difference because we're just on that 4280. But when we go to the back end, we can now see that our functions are coming from 7073. So we've just got that extra step of control in what we want to do to make sure that we have the environment running as we want to. Next thing, how can we do changes to our application here? .NET 6, we have hot reload. And if we run it like this, we have hot reload for Blazor applications too. So let's have a look and do some changes. Let's go to the home page, and we have Debugging Static Web Apps as our title. Have a look in our code and go to the home page, the index, and at .BLD, if we save this, and everything goes as it should do, we have hot reload of changes successful, and then we have at .BLD. So we have that hot reload goodness. We can now just code away. If you're lucky enough to have two screens, it's great. You can put VS in one screen, put your browser in the other, and as you type and save, it just appears on the screen for you. Almost. There's one proviso, and oddly enough, half the time, I forget some English words. And here I'm going to use a nice Dutch expression as een addertje onder het gras. And that is, if you do too much of a change to your application, hot reload fails. And it says, nope, can't do this. You've got to restart your app. The .NET CLI has a wonderful one for this. You just get a, hey, do you want to actually restart your app? You press yes, and you continue. When you're running inside of the SWA CLI, that input never quite gets through, so you have to cancel it and restart it. It's a pain. Happens often, but not too often in my experience. Your mileage may vary, of course. So that's one way that we can use our applications. Now, obviously, we can also debug to the console. For time reasons, I'm not going to show that here, but in Blazor Static Web Apps, you just do a console.log. Obviously, if you're using Angular, you just do a console.log. Console.readline in WriteLine in C#, console.log in Angular. So you can get your information out of your application as you want and do what works for you. I end up using a mixture of everything depending on the problem that I'm trying to solve at the time. The next one that I want to get onto is actually controlling the host and the port of the .NET CLI itself. Now, we see that it automatically loads on 4280, but the same as with our Azure Functions, there's no guarantee that that's going to be available to us, and we might want to run on a slightly different location. Thankfully, we can do this. We have the ability to set the port number that we want to run on. So let's bring up our last command, and instead of API port, it's just simply port. And that equals, what's a nice one? 8080 is a nice one, because nothing ever uses 8080, does it? If we run this now, we'll wait for this to start up. Come on, you can do it, little computer. And now we're running on localhost 8080. So if I refresh this page, nothing's going to happen, because we're not there anymore. If I change to 8080, and I don't add weird characters at the end, we get our application back. You can also, I must admit, in my day-to-day use, I haven't had a need for this, but I think it's kind of neat, so I want to show it anyway. But we can also change the host that we want to run on. And that is just as simple a change. And that is by adding yet another parameter, host, and that is also an equals 127.0.0.100. Let's try and run on that IP address, shall we? We can restart again. We can keep our fingers crossed. And now, again, localhost, that's going to die because we're not running there anymore. So let's change it to 127.0.0.100. And we have our application back. This functionality is a little bit finicky. It does work until it doesn't. And when it doesn't, you don't get the nicest error messages out of it. Let's run a command, if I copy the right command, that is. Thank you. Let's run a command. And what we're going to do is try and change our port to 5001. Now, we can't do that because 5001 is going to be in use by the .NET runtime for our HTTP connection to our application. So what happens in this case? It starts up, it runs, everything's looking hunky-dory. And then when we get to the end, we don't get an error message per se. We just get one line at the bottom saying, node exited with code 0. Awesome. If you don't notice that when it's starting up, you can sit staring at this screen for an age. Don't ask me how I know this. The other one that we can do, of course, is run on an IP address that we're not allowed to run on. So let's try that one now. This one has an even weirder way of behaving. We run this, we're trying to run on 30.30.30.100, which I'm not allowed to run on, and this is literally all that the CLI will do now. So be aware that if you are using these two parameters, there's some quirks in there. On to what is probably my favorite part of the CLI and the bit that makes using it so amazing. I want to go to the production version of this site that I'm showing you. And here we have, you can see it's exactly the same as it was before. What I've not talked about yet is this auth info in the top, this not authenticated, and this login button, which has hideous CSS styling. Sorry about that. And this allows us to tap into that built-in authentication behavior of the static web apps inside of Azure. So let's log in, and I want to log in with GitHub. So I click on the button. Azure does its thing. I actually log in with GitHub. You can see that I'm now authenticated as Stacy Cash, and I've got my little name on this button, and I can log out and leave again. The way that that happens simply doesn't exist on your local machine. That is all magic that happens inside of that static web app resource. How are we going to code against this locally? Well, thankfully, the static web app is going to do that for us. Let's go back to a nice simple version of our static web app, so we've not got too many different parameters running. And let's see what we can do locally. So the static web app, we'll close this old one, it replicates this logging, this ability to authenticate yourself, simply by providing us fake endpoints for everything that you get inside of the Azure resource itself. So say I want to log in with Twitter, I get this page, Azure Static Web App Auth. Here I get to be whoever I want to be, and I get to give myself whatever roles I want to give myself. So we're going to have a username of Twitter test because we're developers and naming is hard. And the only roles that Twitter test is going to have is anonymous and authenticated. Simply, you know who I am when I am using your app. So we'll log in now. And we get this data out again, the same as we do in our production resource. We have Twitter test, we are authenticated, and we have our Twitter test back down here. It's behaving exactly like production. Almost. Remember what I said? It replicates, it doesn't run it locally. Second one that we're going to do now is log in using a different username, and we're going to give that user a different role. Because inside of my login component, where my login button lives, we have a little thing here saying that if I have the role of site owner, I don't want my name on the button. I want to know that I'm admin. So stick that on the button. So the way that we're going to do that is by going back to our app. We're going to log in again. Going to log in with GitHub. And we see here that I have username of BLD-conf. And BLD-conf is site owner, only that's not the right site owner. That's the right site owner. And now when we log in, we can see that we have that extra role at the end, site owner, and we can see that we can use that inside of our app. Why do I think this is so powerful? Because we can play with every different connector that we want in production, and we can play with every role that we want in production without having to spin up different users for every different scenario that we have. We can just fake it till we make it. Can we use this in the back end as well? I'm really pleased to say that, yeah, we can use this in the back end as well. Inside of this auth info, let me just quickly switch to the front end app. This part here, I could get this out of the client. I don't need to do an API request to get it, but I want to show you how to use the API, and I couldn't think of anything else to do at the time. So we have this auth info function, and this is basically getting access to this header. This header is added to your request inside of the Azure Static Web App. It doesn't come from the client, and that gives us all of our authentication information so that we can reuse it and work against it. So we can get client or user-specific information. We can store user-specific content, can load user-specific content, all the stuff that we want inside of an app. There's something here, which if you start with authentication on the Static Web App CLI, you need to know, and that is there is a wonderful red herring built into this. There is also a bearer token that comes along with this request, and that's a JWT. If you decrypt that, it has all the information that you need, and you can think, great, my application's going to work perfectly. Then you move to production. And in production, that bearer token contains completely different information, again, replicating a static web app, not running an actual static web app locally. You have a subtle difference in behavior that can really make you scratch your head when you deploy to production. So that's almost everything for authentication. There's one last one that I want to show you. It's not the Static Web App CLI per se. Again, it's duplicating functionality in production. But if you are running this and you really want to see what your user has for roles and things like that, and you just want to check what's coming through, there is a great URL, auth/me. Why am I typing in capitals? And if we go to auth/me, you get all of the information back about your user. And in fact, this is how we also get that information in our client application. There is a call done to fetch this information. So that's everything that we can do about authentication. We can run it all quite happily locally. We can replicate what we need to replicate. And we have a really snappy, quick developer inner loop when we want to develop all the cool stuff that we want to give people. Last but not least, on a lot of these pages, you will have seen that I can do refreshes. So if we go into the famous Blazor counter page, which I'm sure has been demoed a billion times by now, we can count, it's all awesome. When you hit F5, even though I am running a static web app, it finds my data. Now, this is cool because you think, woohoo. Then you deploy to production, and when your users hit F5, they will get a 404 error. Because in Azure, we are serving pure static files, and it doesn't know how to get to roots. That's all built up on the client side. It is client-side Blazor. When you run locally, you are running with that .NET Watch run, and that will do some clever routing for you to make you think that things are working better than they are. What I recommend is really running your SWA CLI against some static content to make sure it's working as you expect it to. So let's do that next. We're going to quit this again. No, I don't want to paste, I want to quit. What we're going to do is check that I don't have a dist folder already. We're going to go into our client, and we're going to publish what's in the client. So .NET publish, and we want the output to go to /dist. So now we're going to take that application that was running in the .NET CLI, and we're going to turn it into actual files that we need to serve. That's done there. That's great. And there's one last thing that I want to do, because otherwise this isn't going to be a good demo. Yeah, I want to rename this file to be this file.ignore, because I want to show you it broken before I show you it working. So now we need to show our static content. How do we do that? Well, basically, instead of saying the URL that we want to talk to, we say the folder where we can find our static content. And the SWA CLI is intelligent enough to go, this isn't a URL, I need to serve files from the disk here. And then, of course, the API location, because they're not static files, can just be loaded in exactly the same way as it was before. And, you know, it really helps if you do the right text. So we need to start it, of course. So now it loads up. It's reasonably quicker than it was because we're no longer loading the full .NET runtime. And now if we go to here and we hit refresh, oh no, we have a 404 error. How are we going to fix this? Well, we're going to fix this with that sneak preview that I gave you before I ran the demo using a static web app configuration file. I'm not going to go into detail here because that is a whole other talk. But this file allows you to control your static web app. It allows you to control authorization. It allows you to control fallback routes, URL rewrites. It is a truly spectacular piece of technology. Right now, we are just going to use the very, very basic of that technology. And that is simply a fallback URL to say, if you can't find this particular thing, go to index, and on index, Blazor will sort it for us and deal with any 404s that we find. So we need to change this JSON file back again. .ignore. Now when we rerun our static web app, if everything's gone well, I should be able to restart this and it will be awesome. And there we have our counter back. Now, I just have my config in my root folder. It's not where you'd have it in production, but it works best there for this demo. The last one thing that I want to do before I stop is I want to get rid of the complexity that we have in our commands. You've seen that some of these commands have been really complex. They're really long, and you don't want to remember them all the time, especially when you're just stopping, starting. Thankfully, the CLI itself also has a config file. And that file is reasonably simple. We have our configurations, and for each configuration, we can set the options that we want. So here we're saying the context is that static folder. Here we're saying the context is that local host, and we need to run .NET 2. So if we run this, where is this? This is in our CLI folder, our config folder. So now if we say SWA start, we're going to point to our config. If it's in the same folder as you're currently in, it will pick it up by default. And we're going to say start static files. I do the static files because it's the quickest one to start. And there we go. It's up and running with way less options. There are some downsides to this. First downside is that if you're using this config file, you have less control actually at the command line to be able to do things. You need to either have your config in a different folder, as I've done here, or you need to list every single one of the configurations that you're expecting. I think that was all of the demos that I wanted to go through today. So I basically just want to thank you all for your attention this evening. There is a QR code on the screen right now. If you scan that QR code, it is going to take you to the GitHub repo for the Static Web App CLI. Go and take a look, see what it can do. It is still in preview, so be a little bit wary, but play anyway. Thanks for your time. And yeah, do we have any questions?
Thank you so much, Stacy, for the insights of maybe what looks very static, can be quite dynamic in terms of content. So thank you very much. I see we don't have a lot of questions, but I also heard that in Studio One they are already ready. So I have one question, maybe also for the audience. So we're talking about static web apps basically, but you also showed that there's an Azure function in the background.
Yep.
So we can do some dynamics there. Can you maybe give some insights in what do you think are the typical use cases for static web apps, and maybe where you guys are using it at your own company?
I think a great use case is one that Aaron was talking to me about earlier that he's been using, and that is to, if you are doing maintenance on your site, it's really easy to just spin up something to have as a placeholder while that's happening. I think that's one great simple use case. Another one would just simply be anytime you have a front end which needs a hook to an API. So we are looking at maybe using this for admin modules in our application that we're going to be doing over the next year. But there's also no reason why we can't actually use that as our whole front-end application. We get rid of hosting that we need for that full-blown web server that we're running right now. And using that API, you can direct the calls to where they need to go in the back end. And you can plug it into its own system. If you're using one of the standard tiers, you can put it inside a networking blob. Yep. So it isn't available to the outside world. You can still hook it into the application gateway, and you can really just use it to simplify your front-end hosting.
Makes perfectly sense to me. I have one final question. I don't know if you have the answer, but you mentioned so many tweaks and how to do the debugging. Is that somewhere on a blog that you have where you have some of the, let's say, getting started tweaks on running it locally?
It isn't yet. This repo I am going to put online. I'm slightly busy over the next week, unfortunately, but within 2 weeks, I want this repo online, and I'm going to put basically just a load of different commands in there, a little bit of information about what those commands do. And if anybody's following me on Twitter and I've not done that inside of 2 weeks, please come and hit me and I'll make sure it happens.
Thanks. I will definitely have a look. Thank you so much, Stacy, and thanks all.
Thank you for having me.